Okay. Hello, my name is Maisha Zinni, and for my final project, I did a ping pong game. So I imported Turtle ST and I imported an operating system which allows us to create a game. I did win is equal to t dot screen, which creates a window. I titled it Let's Play Pong. Its dimensions are 1000 horizontally and vertically 800. And I guess to visualize this to make it easier to understand for the rest of the, presentation, imagine this whole screen as like an XY coordinate plane. Here's the origin. So if you go this way, given that the width is 1000, this way the max value is 500, and this way the minimum value is negative 500. So 500 gives you 1000, and then same for vertically. On top here, the max value is 400, and on the bottom here it's negative 400, which means 800 pixels in total. That just sets up the dimensions, and win.tracer just sets up the speed of the game, and I let that be 0 because I don't want anything too crazy. The first object I created is a ball, so I did ball is equal to t.turtle, which imports a turtle being an object. The speed of this object is 0, and this refers to the speed of the animation and not the speed it moves at. I let its shape be a circle and its color be orange. And ball.pinup refers to allows this ball, my bad, to move across the screen freely without leaving a trace or like without creating lines, right? So if I didn't have that line there, as this ball moves, there would be a line like following it. It would create a line as it moves. So I just included that to avoid that. Its initial position is at the origin 0, 0. And I created two variables, X movement and Y movement, to define how many pixels the ball moves at. So given that both are 1, this means that the ball moves to the right by 1 unit and up 1 unit. I then created the paddles. So I named this object, the first object, boy, t.turtle, and this paddle had a speed of 0. Its shape is a square, its color is pink, and I did the same thing, pen up, right? This allows for this paddle to move up and down without creating like lines or like a path. Its initial starting point is negative 450, right? So this means that it starts here, negative 450, and it's in the middle, so there's no y coordinate. Its starting point, it's right here, right? This is negative 450, and this is 440. And I let its dimensions be kind of switched around. So I stretched its width by 5, and I left its length. So the width goes this way, and this is 5 times longer than its length, which is this way. And I did the same thing for the right paddle. I named it girl. I gave it the color blue. And instead of its initial point being negative 450, this time it's 450, right? Because it's on this side. So these are like the positives. And I also stretched it in the same way. So now we're going to define how the paddles move, right? So we have to define each movement of each paddle, right? So the paddles can only go up and down. So we're going to define a function for the up and down movements of each paddle, if that makes sense. So the first function, def boy up, this defines the way the left paddle moves upwards, right? So y is equal to the y coordinate of boy, this, plus 40. So that means that with each click, or like every time you move this paddle, it goes up by 40 pixels, right? And so boy.setY just set this new y coordinate for the left paddle. And once again, we're only using y coordinates because these paddles are stuck at the x coordinate of 450, and they can only go up and down. And so for boy down, I did the same thing, but negative 40. So with each click, or like every time you make the paddle go down, it goes down by 40, what's it called, pixels. I did the same thing for the right paddle, which was girl. It was y girl y core plus 40 and then minus 40 for up and down. So I'm sorry, I'm sick. Okay, so let me see something. Okay. If we just have this defines the functions of like their movements, but doesn't let a player actually like move these paddles, right? In order to do that, to let somebody actually like play this game, we have to like associate each movement to something on the keyboard, right? To let us play. So win.listen just tells the system to listen for keyboard inputs. Win.onKey press tells you that when you press the letter W, boy goes up. So that triggers a boy up function, right? So right now I'm pressing W and boy is going up. For boy down, you press S. So now I'm pressing boy down. I'm pressing S for boy down. For girl up, you press I, and for girl down, you press J. So here I'm pressing J, and now I'm pressing I. J, I. W, S. Simple. Now it's time to actually control how the ball moves, right? This is kind of the hard part. What is happening? Right here. So the main game loop. So in order for so we have while true win.update. So this just allows the game to constantly update and refresh itself. So it just doesn't freeze and die at the first pixel or the first iteration. So now when it comes to moving the ball, right? So ball.setx just allows the x coordinate of the ball to constantly change, right? So that is defined by the x coordinate of the ball at its prior position, not necessarily its first position, but just at the position it was just at, plus ball movement, right? And earlier we defined ball x movement and y movement to be 1 and 1. That means it moves to the right by 1, moves up by 1. So ball.setx and ball.sety just says that, at each iteration, the ball starts at the x and y coordinates of 0 and then moves up and to the right by 1. So now we're going to set up borders, right? Borders are important because if we didn't have them, if the ball was moving this way, right? If we didn't have this border, it would keep going this way and it would just leave the screen. So we need to set up borders in order to ensure that the ball stays within the screen. So the up and down borders were established by if the y coordinate of ball.y core is greater than 390. So that means that this is setting up the top border, right? Hold on, I don't know why this is, how to hide this. So up here, so the max y coordinate is 400, right? But I just gave 10 units of space because the pixel itself is 10 units and I didn't want like half the ball to be out of the screen. So I let the border be at 390, right? Up here. So if it passes 390, right? What I let it do is if the y coordinate passes 390, you set the y coordinate of the ball to be 390. So it's forced to stay there at 390 and then it switches the position or the direction the ball is moving at in the opposite way, right? So I did that by doing ball y movement is equal to ball y movement times -1, which just reverses its direction in the y direction. And I did the same thing for the bottom border. If it were to pass or like surpass -390, right? If it were to go to below this point, then it gets stuck at, or it gets set at -390, and then it goes right back up. So for the left and right borders, when it comes to like games like ping pong or like air hockey, whatever, right? The goal of the game is to get it past the other person's paddle, right? So say this ball, right? In this case, it just went this way, blue, quote unquote, won, right? I don't necessarily have a scoring system here, so I can't say win or lose. But the point of this game is to make sure that the ball goes past the other person's paddle. So we don't need to set up borders there, but we do need to set up a system in which say it does go past the left or right border, how to reset the ball, right? So I set up, so if the ball, the x coordinate of the ball, right, is to go past 490 right here, then you set the ball. So this is kind of like winning, right? 10 points just to like, or 10 pixels, 500 minus 10 is 490. 10 pixels just to like, give it space to like actually hit the wall. So if it were to go past this point, that means the other person quote unquote wins, and it gets set back, the ball gets set back to 0, 0, 0, the origin, right? Hold on, let me see if, well, let me just show an example. So watch, it's gonna go right back to the origin. So if the ball, this is for the right border, right? So if the x coordinate of the ball goes past 490, the ball goes back to the origin and it reverses direction. And same for the left border. If the ball goes past negative 490, then it also goes back to the origin and it reverses direction. So that's pretty good. Now, Turtle doesn't have a set function to like take into consideration the collision of objects, so the collision of turtles, right? So if I didn't have all this right here, or if I just stopped it right here, right, I just ran this code, the ball, if the ball were to like collide with the paddles, it would go right past it, right? So we need to create a function that accounts for when the ball actually hits the paddles, right? So the ball and the paddles could interact. So if the x coordinate of the ball is greater than 440, meaning right here is greater than 440 and less than 450, which is here, right? So if the ball is here, let me just go lower. So if the x coordinate of the ball, right, is greater than 440 and it's less than 450, and the y coordinate of the ball is less than the y coordinate of the paddles. So right now for this first function right here, I'm working with this paddle right here, right? Or actually, let's just go to this one because it's easier to see with the code. So if the ball, the x coordinate of the ball is less than negative 450, but greater than negative, oh, I'm so sorry. If the x coordinate of the ball is less than negative 440, but greater than negative 450, so within this range right here, and the y coordinate of the ball is within the range of this, the height of this paddle. So that is shown by doing the y coordinate of this paddle, which is like, I guess, the middle, plus 40 on the top and the bottom, right? So if it hits any point along this line, if the coordinates of the ball satisfies these two conditions, then in that case, that I guess counts as the two things colliding, right? In that case, you're gonna set the ball, the x coordinate of the ball to be 440, as in set it to be here, right? You're gonna set it to be where the two meet, the ball and the paddle meet, and then you're gonna reverse the direction, right? And you do the same thing for the right paddle. So let me show an example. Oh, let me see if I can make it. Oh, no, I did not make it. How about this one? So here, because the coordinates of the ball was within the coordinates of the paddle, you set the x coordinate of the ball to be at 440, which is exactly where the outside border meets the ball. And then you're going to reverse the direction to kind of like make it look like it's bouncing off. And yeah, I do that for both sides. And then I run it. So I don't know if I mentioned this earlier, but while true is just ensures that the game keeps refreshing and that the game runs smoothly. So to play this, I'm terrible at this. I have the worst hand-eye coordination. So I'm pressing J, and you saw how it just bounced off. Oh, bro. Oh my God. Okay. So the game could be faster. So I could fix that by changing the speed of the game or the ball. Oh my God. But yeah, this is just how you play. And I just lost there. But yeah.